And then when I'm looking back at these recordings, unfortunately your face is in it. I'm sorry that you're in the recordings. But it is what it is. And on the right side, I can clearly see the work over there. So that's what you should be seeing if I make a video of this. Alright, you see that? Okay, so this means I'm taking the F1 and I'm plugging it into the G1. F, you know what? Let me double check that. It might be the other way around. Let's see. I think that means here. I got a good picture of it. X is 1. Yeah, that's what it is. So if I'm looking at my picture here, I'm taking this and I'm plugging this right here. So that'll give me 4 over 7 over x right there. And that's where it gets a little dicey. Because right there I gotta make this a common denominator. I gotta times this by x over x to make it a common denominator. That gives me 4 over 7 over x minus 3x over x. And then when I condense that down, that gives me 7 minus 3x over x. It's kind of weird. Now I'm going to flip this guy around. Take that top part, write it as a fraction. Take that bottom part, flip it. And then you're going straight across right there. So that gives me 4x over 7 minus 3x. So that answer, that's this one right here. And then domain can't be anything that makes this be 0 or anything that makes this right here be 0. So the two bad numbers, of course, are 0 and 3. Because, see how 3 makes that 0 right there, positive 3. So those are your bad numbers. So domain might be kind of weird. You might have to write this as like negative infinity, 0, and then from like 0 to 3, and like 3. I think that's how you're going to write your domain. That's kind of weird. I think though, I look back that we did these, but I can't find the picture right away. And I think on these it's best that we don't spend super a lot of time on each one. We just move on, because it will just adjust what it is, and it is what it is. See that 4x over 7 minus 3x. Yeah, I forgot to do those. I think that's it. Here we go. So we got length. The rectangular box is 4 times its height. So the length equals 4 times the height. The width is 6 more than the height. So the height plus 6. The volume equals 47. Alright, I think I got what I need. You want to switch it over so I could show you on paper there? Or whatever. What's up? Well, yeah, you won't be able to. What I see right here, there I see it, where you'll be able to see it on the video. Unfortunately. Is that okay? Yeah. Because I don't want you to look back at that little corner. It's the tiny little right corner. I don't think you'd be able to see. Alright, so this is volume of a rectangular prism. Looks something like this. Like that. And it's giving you this length right here is 4 times the height. It's giving you the height. And it's giving you the width is the height plus 6. That's where I got all those numbers. So it said the length is 4 times the height. The width is the height plus 6. And then you got the height right there. So if I times all 3 of these together, it should give you this. So if we times those, that gives me 4h squared. If I times that, that gives me this. If we rearrange that and graph it, I think on your calculator, you're going to be graphing this. If I rearrange it and get that 47 on the other side equals 0. So I think you're going to have to go to that graphing calculator and we're going to have to find like the maximum and find those numbers. So let's go back to your machine there. Oh, it wants us to solve it. Shoot, how did... Okay, you got that? So that would be y equals, and then that's 4x squared. We'll just use x. I'm sorry, 4x to the third. So that x to the y button right there, and then the third. Plus 24 h squared or x squared. There you go. Minus 47. Graph that. Alright, is there a way we could expand that out or something? God, I don't know if I did this right. So I got the length is 4 times the height. The width is the height plus 6. Then you got the height, 4h squared. I'm going to graph that in Desmos real fast. Or I guess, shoot. I'm not sure, that graph's not looking correct. Maybe. I mean, if you, yeah, I don't know. I forget how this works. Yeah, I don't know. I'm gonna do this on Desmos real fast, see what happens, see what I get. Yeah, it gives me a weird graph, plus 47. Um, so it looks like I would put in 81 inches in there, maybe 81 inches. Let's try that. Let's move on. Because looking at Desmos there, when I zoomed it out, that high point on the left was 81 for Y, so we'll just take that. Whatever. 2 decimal places. I don't know. I would just skip that one. We gotta move on. I'm gonna write those down so one day if you see those again, we'll maybe remember to figure out how to do those. Alright, least common multiple. No, I don't remember least common multiple, but I know how to do least common multiple. It's easy. Whoops. Alright, so least common multiple, you ready? So 4b and 10, is that 10n right there? Is that what that was? 4b and 10n? Alright, so if I look at the least common multiple for the numbers, the 4 and the 10, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. 10 times 1 is 1. 10 times 2 is 20. So it looks like the lowest common multiple for the number is 20. And then for these variables, the lowest common multiple comes from you just timesing those. So that's your lowest, that's the answer to that one for sure. Yep. The lowest multiple for the numbers, and then b squared, plain old n. Is that all together? Okay. All right. So this is another one of these where I plug in one into the other. So f of x, I got g of x, all right. You want to switch over? I'll show you. Alright, so if I take this, plug that in there again, it gives me this. And then that's really weird because I got to common denominator it. I got to multiply this top and bottom by x to make an x down there. That gives me 5 over x minus, this is still 3 in disguise, but now it has the denominator x with it, so I could subtract that one. Leave the top part alone. The bottom part gives me 5 minus 3x over x. That's the weird part where I take that top part as a fraction, and I take this bottom part and I flip it. And then you times straight across. So it looks like x squared for that one, and then your domain looks like 0 and 3 again. Looks like those are the bad ones again. So negative infinity, 0, union 0, 3, and then I believe, yep, I think, pretty sure. I mean, I googled that on my phone and I found that. Alright, so this one, use the graph to find the average rate of change from -1 to 5. Okay, so let's write those points down. So -1 for x looks like 3 for y. And the point for 5 looks like 5 for x, -9 for y. Alright, got it. Ready? Nope, I do not. Okay, so those are the coordinates I spoke out there. Rate of change is slope, which is your change in your y numbers divided by your change in your x numbers, or rise over run that you got to memorize at some point. So I'm going to find the difference of my y's and divide it by the difference of my x's. So I'm going to go right to left, keep that pattern, -9 minus 3. On the bottom, keep that pattern right to left. It's going to be 5 minus -1. That's a little trickier because you're subtracting a negative. Gives me -12. This turns into plus, so 5 plus 1 gives me 6. So I think you just write -2. No, that one just wants you to write it as a simplified answer. Okay, compound interest. Let's see, let's write those numbers down. So 3,000, 9.8%, semi-annually, 3, 4, 6, 2. How long? All right, you ready? This can be a good one. We'll see. I think I remember how to do this one. Compound Okay, so the formula, I had to look it up because I don't have it memorized, is that A equals P1 plus R over N to the N T power. Alright, so it wants this number right here, 3462. It wants the initial number right here. I have this. I have the rate as a decimal. The number semiannually 2. I know this number is 2, and I know this is t, and that's what I'm going to be solving for right there. So this problem here, it's probably, if I divide by 3,000 first, let's do that first. Let's see what my calculator says. So 3462 divided by, that gives me 1.154. This right here, I don't have my scientific calculator. Let me look for it. Sorry, I don't know where that is. You do? Okay. Because that 1 plus point, yeah, you're going to end up, yeah, you need to know what that number is. So let's see, 0.098. Okay, divided by 2 plus 1. It looks like 1.049. I believe. And then I'm going to have to log this one here, if you remember. I'm going to write this as log 1.154. Over here, I'm going to write it log 1.0492t. Got plain old 1.49, you sure? You did 0.098 or 0.98? Okay. That's okay. Yeah, a little decimal there. And then for this one, I'm bringing this down. So I'm going to write this as log 1.154 equals 2t log 1.049. I'm going to divide this side and this side by 2 log 1.049. And that will cancel out all that stuff over there and leave you just plain old t, which is what you're solving for. And then it's going to be up to you to type in log 1.154 divided by a 2 out front, log 1.049. Pretty confident about that one there, because we just did those recently. So fresh, it's log 1s. There you go. Cross your fingers. That looks reasonable. Nearest hundredth. Yeah, good job. So I'm going to set this up in Desmos for sure. Let's see what Desmos tells me. Y equals 4x plus 6 x plus 2. Alright, so it looks like vertical, horizontal, asymptote. So it looks like you have a vertical asymptote at -2. So if you want to start on that, let me give you a picture of what my graph looks like. So the picture I'm sending you, it looks like you got a dotted line going through -2 on the x-axis there. And then looks like you have a dotted line going on +4 horizontal. Those are your asymptotes. There you go. And now for points, it looks like you have 1 point for sure on negative what is that coordinate? Let's see, trying to look down here. It looks to me like -12. Wait, what is that number? Oh no. Don't make. Sorry, dogs are barking. I guess we'll have to just plug in a couple of coordinates. It wants 2 points on each part of the graph. Alright, so we're just going to have to plug in some numbers. So I'm going to write down that function. That's 4x plus 6 over x plus 2. It looks like I'm going to plug in possibly -3 and -4. And then looks like I'm going to plug in -1 and 0. Alright, so let's use Alex for that. For your calculator.
Yes, sorry, Bob.
Alright, so plug in 4. Open up a parenthesis and let's just do it all on the Alex. And then just plug in -4 right there. Close that, plus 6. You gotta close, there you go. And if you could get that as a fraction, you might have to use parentheses. Oh, there you go. You'll get it. 4 times -4 plus 6. Perfect. And then that would be -4 plus 2 right there. Perfect. Perfect.
Yes.
All right, so it looks like 1 point is negative 4, 5. Let's plug in another one. Let's do that again, but plug in negative 3. So you got to hit that fraction button first, though. There you go. So 4, negative 3 plus 6, and then negative 3 plus 2. All right, so yep. So it looks like you can do that part of the graph. So negative 4, 5. And I think, how did you do that? I forget how you did this. So 1 point. Yeah, I forget how to. Okay, yeah, so that's how you do it. So negative 4, 5. And then the other one's negative 3, 6. There you go. What happens if you have that little curvy line? Does anything happen there? What? Alright, let's not plot it yet. Alright, let's do back to calculator. Let's go 4. And then remember, you got to hit that division button though first. So 4 times negative 1 plus 6. On the bottom, negative 1 plus 2. Yep. And then if you plug in 0 to the other ones, you're just going to get 6 divided by 2, which is going to be 3. So the other one is 0, 3. So let's plot those 2 points. Let's plot negative 1, 2. And 0, 3. There it is. Alright. Yeah, sure look a little wacky there first. Okay, let me write this down. 9y minus 3. Alright, you ready to switch over? I'll show you. Alright, so I'm going to distribute this. And that gives me the same 9y minus 3 over there. Over here I get negative 6y minus 18. I'm going to add 3. And that gives me 9y equals negative 6y minus 15 right there, I believe. Add 6y. And that gives me 15y equals negative 15. And then dividing by 15 there gives you negative 1. There we go. Got all that on video too. So negative 6y minus 18. Add 3. That looks good. Pretty confident about that one. Just did these ones. So it says initial is 40, 124 fish after 9 years. How many fish after 12? Yeah, we just did these, remember? Alright. And that's y equals y0 e to the RT, right? Okay. So plugging in those numbers. So y, you gotta just plug those in, I guess. The little boxes right there. So that one is 120. Oh, wait a minute. Oh, shoot. Let's see. Okay. No, you know what? I think these are a little bit more complicated than that. Let me try to find one. Oh yeah, these are a lot more complicated, I remember. Yep. Okay, I'm ready. You want to switch over views? Okay, if I remember, you put 124 here, and you put 40 here, and then I'm going to write this as e to the 9r power. And then I'm going to use the natural log rule. I'm going to natural log this. I'm going to natural log. Oh, whoops. Before I do that, I'm going to divide by 40. So let's see. Can you do 124 divided by 40 in your calculator? 3.1. So that gives me 3.1 equals e to the 9r power. Now I'm going to log it, natural log. So natural log 3.1, natural log e to the 9r. Remember, these cancel, and that leaves me natural log 3.1 equals 9r divided by 9. And that gives me what r is. So it's going to be up to me to go back and plug that in to the final part where I write it as y equals 124 to the ln 3.1 over 9t. Yep, feel pretty good about that. I remember these for sure. And then the next one, you're going to plug in 12 right there, will be on your calculator. So the next one will be you doing the math where there's a 12 right there. Alright, feel pretty good about that one. We just did that. So that first one is what, 124, and in there you want to use that fraction one.
Luke. You might have to go pick him up.
Yep.
Trying to make
would be line over there.
over 9. And then the bottom one, you'll use that calculator over there for sure. So 124 e to the x. There you go. And then times 12 up there, up high with the exponent. Yep, I think that's up high. Yep. Yeah, I think that was good. No, that wasn't good. What you had before. Nope. There you go. Perfect. Nope. You almost had it. There you go. Perfect. There you go. The nearest whole fish. Yes, ma'am. Okay, so we got 1,700. We got 6% compounded continuously. How much after 4 years? All right, pretty sure this is a just simple interest, I think. Let me double check. Okay. Yeah, so this is a formula, simple formula. A, the amount, is the principal times ERT again. So it wanted, can you go back to that question? I'm sorry. Yeah, I think they want us just to use that formula. So if you want to go to your calculator, I think we could use that right away. So that's what, 1,700 times that e to the x button. What was the percent? 6%, so 0.06. And that was times 4 up there. There you go. Nearest cent. John? I think so. Alright, let me look for this one. I know we just did this. We want to get these right. Trying to find it. Trying to find it here. I know I have it. Here it is. I got it. Oh, hold on, let me write those numbers down. So it's 8 minutes, 2.9 milligrams, exponential growth, doubling. All right, got it. You ready? And then 13 minutes at the end. Okay, so for this one, it's a little trickier. The y to the 0, the initial, I know. But this final amount, I gotta go back to the initial and I gotta double it. So that gives me my final amount right there. So if you have a calculator, if you could multiply 2.9 times 2 for me, let's see what that number is. Yes. 5.8. So that number is my final amount. My initial amount is 2.9. E stays E. R stays R, but I plug in, 8 for minutes, 8R. You see that? So now I'm going to divide by 2.9. So I need you on your calculator to divide 5.8 by 2.9. Two? Awesome. So that just becomes 2 e to the 8r power. I'm going to use the natural log button now. These cancel. Oops, I forgot my 2 right there. And I have natural log of 2 equals 8r. Divide by 8. And that gives me just the r part is ln 2 over 8. So that goes right back here. So your final answer is y equals the initial amount 2.9 e to the ln 2 over 8 times t. And then your final one is going to be you taking that and plugging in 13 for t. Yeah, those are familiar. We've been doing those, if you remember. Feel pretty good about those. Done with those. Yes. So that first one, you got to do that first one, right? Yeah, so that one's going to be 2.9 e to the ln 2 over 8. Oh, no, not that one. There you go. Hit that one first. Perfect. There you go. Good job. How complicated. I think it's okay if you do it like that. I really don't think it makes a difference. So round to the nearest tenth. Yes. Good job. All right, what do we got? Okay, this is decay. Alright, man, they're throwing a lot of these at you. But that's weird that they're having to do so many in this knowledge shit. But that's okay. Because we should be getting these right. Okay, so 320 is the initial. So y to the 0 is always initial. Y is 240 after 16 minutes. And then they want you to do whatever. And then 23 hours for the last one. Okay, ready. You should recognize these two. So I got 240 here. I got the initial amount here. I got the E here. I got the 16R here. I'm going to divide 240 by 320. Not sure what that is. Maybe you could do that. What'd you get? Okay, that's good. Let's use that. Gonna natural log it. I'm gonna rewrite it because the natural log and that E, remember how those cancel always, and just give me the exponent part times the variable. Divide by 16, and that's where they get that weird number you've been typing in the parentheses there for the R number. And then again, back to you, it's Y, the initial 320, E, and then that weird ln 0.75 divided by 16 t, and then that one with the 23 plugged in there for the last one. Good job. What's it rounding to? Nearest whole? Yeah, 2012. Oh man, remember these ones? Holy moly. I gotta look back. Oh, these are a long time ago. Those are those ones we gotta look at that chart. Remember that chart you had? Like case 1, case 2, case 3. No. Oh, you know what? Yeah, we can get these right by using Desmos. Let's do that. Yeah, good idea. So let's Set up Desmos. So that is 3x to the 6th minus 4x to the 5th plus 6x plus 8. I have rises to the left and rises to the right on that one. I mean, this is going up and up and up. Rises to the left and rises to the right. Yeah, it's a U shape, so. And then this one, 5x to the 3rd minus 9x squared plus 8x minus 7. Mine looks like falls on the left, rises on the right. Is that what yours is showing? Yeah, mine's almost straight, but I can clearly see the left side is going down, then I have like a little curl, and then the right side's going up. So that would be falls to the left, rises to the right. Alright, and then one more. Let's type that in exactly. So negative 3x x plus 1 x. What are you getting? Yeah, like an M. So falls, left falls, right? That's what I think too. I think we're good. Hopefully no more of those. Those are a pain. Alright, looks like another Desmos one. Yay. Yep. And I only see one that's even remotely close, so that's that E one, right? But God, that's weird. Because that doesn't look exactly, maybe F? Yeah, look at F there. Because it does go over. Yeah, so F. And then the last one, 2 parenthesis x minus 1 to the 3rd power. Man, love Desmos. Stoked. Such a pain to do it without Desmos. And then x plus 2. Alright, what do you think? Yeah, looks like C to me. It's the only one I'm seeing in close. So maybe we graph this one too, huh? Because Desmos does have log on it. It does, okay. Just trying to get mine working here. So y equals 4. Are you seeing it? Where is log? Okay. Yes. Oh, it is miscellaneous. There we go. Ooh, how did you get that to be the base of 2 though? Oh, there it is. Very nice. See, got skills. So what'd you get?
Well, I mean, a little bit in here, so you might have to wait. Can't let you see it out of your way. You do it over there.
For sure. It looks like you could do your, looks like your vertical up and down asymptote is the y-axis 0. So it's like you could do a dotted line there. And then it looks like the y asymptote looks like it's curving down. Looks like positive 40, but I don't know. Yeah, you can't drag it up there to 40. So maybe another point there. Let's plug in you plug in 1. Let's use our calculator and plug in can you plug in log base 2 and then plug in like a different number and see what you get? Yeah. Well, you plug in 1 and you got 0. Plug in like 2 or something. Let's see, I'll try it too on mine. What was the formula again? 4 log base 2x. There we go. So you got 4 out of that. So maybe 2, 4. Got E right there. Yeah, God, we're doing these wrong. But you know, it looks good. Try that. That looks good. Pretty close to what we got. compounded annually. Alright, so let's write down those numbers. So 45,000, 73,000, 4.25%. Alright, you want to switch over? Okay, so I'm pretty sure I write this as 73,000 equals 45,000 times 1 plus 0.0425 compounded annually, right? Is that what it said? So once a year times 1 times R, I think. And then I want to divide this. So maybe you could calculator that out, divide those out, see what you get. I'll try to 73 divided by 45. Ooh. That's yucky. So I'm going to leave that as a fraction. Yeah, that's a big long number. Alright, so leaving that as a fraction. And then 1, let's see what that is. 0.0425 divided by 1 is 1. So this is 1.0425 to the R power. Someone coming in? I was wondering what's going on. Alright, so I'm going to natural log it. I'm going to regular log it. I'm going to log this side. I'm going to log this side.
You guys should go as high as 375.
And write this as R. 1R. Bring this down. Divide. I think.
By the time I need to use this, it will be out of.
Ooh, I think I did this one wrong. I'm gonna reset this one. So 73,000. The other number was 45,000. Is that right? And that was 1 plus 0.0425 by 1 to the 0.0425t. That's my mistake right there. So this still gives me 73.45 when I divide this out. And this gives me 1.0425 to the 0.0425 times t power. I'm going to log this. I'm going to log this. I'm going to bring this mess down. .0425t log 1.0425. I'm going to divide by these two numbers. So this is going to be, I wish you good luck typing this in, Saber. It's going to be on top log in parentheses 73/45 divided by a huge mess on the bottom, 0.0425 log 1.0425. Holy crap. Good luck. Got it. So log, and then inside there, perfect. There you go, 73/45. Good job. No problem. Bottom. Yep. Yes, good job. Whole near number. Nearest whole. Smallest possible whole number. $273, I guess, yeah. Yeah, it looks like, yeah. That's not, yeah, it would take a long time at that interest there. I guess, I don't know. We'll see. I think that's right. Alright, so those points are -2, 1, 1, -2, 2, 0, and 2, 2. Nope, you're going to use that one on the right. Alright, domain are all the X numbers. Are you ready? And 2. Then range are all your Y numbers. Yep. And then range -2. Ooh, this wants set notation. I think that's it. I don't know what that other button does, that little bracket button does. Oh, you know what? Erase all those, and we got to put those answers in those brackets. Because that's the set notation. There you go. Yep. All in one bracket. And then the range, all those numbers that we did. So -2, 0, 1, and 2. There you go. Right, let me write that down. 3x minus 4 plus x divided by a 1 over x minus 4. Alright, you ready? Let's get this on tape. Yep, I'm ready if you want to switch over. Okay, so I'm going to have to do a double common denominator. This one on top, I need to multiply this top and bottom by x minus 4. The problem on the bottom, I gotta times that top and bottom by x minus 4. that gives me that same 3 over x minus 4. And then over here I gotta distribute, and that'll give me plus x squared minus 4x. On the bottom I have this, and over here I gotta distribute, and that gives me x minus 4. Now, since these are common denominators, I'm going to write the top part as 3 plus, whoops, 3, my bath later tonight will be nice enough.
No, I'm taking another one before you get it. Are you actually? Oh yeah, that was.
Sorry, I was talking to my wife. Alright, so 3, let's write it like this. How about x squared minus 4x plus 3 over x minus 4. And on the bottom I have x minus 4 over x minus 4. How does that work? Oh, I'm sorry. 1, 3 plus 1. So this becomes negative 3 down here. I'm sorry. Let's double check that. So the top part of this is good. X squared minus 4x plus 3. That's good. I'm going to take this, flip it, and times it by that top part. So that gives me x squared minus 4x plus 3 over x minus 4 times x minus 4 over x minus 3. These cancel. This, I believe I'm going to have to factor that and simplify this piece on the bottom. If I take this and factor it, I believe negative 3 and negative 1 are two numbers that factor that. So after all that, I get x minus 3, x minus 1 over x minus 3, and these cancel. After all that, it's x minus 1. Yes. Product of linear factors.
Hey! No! No, ma'am. This should be with the seasonings, no? Are you using this? Do you want it above the toaster or down there with the seasonings? Above the toaster.
Probably 1 is a 0. I have no idea. You want to switch over? I think I kind of know what they're looking for on this. So I'm going to take this top part and I'm going to factor out an x squared out of it. And that's going to give me x plus 1 right here. Because that will give me x to the third if I was to times that, plus x squared. Over here, I'm going to factor out a minus, and looks like 2 is the number that goes into both these. 2, maybe, yep. And that gives me 4x plus 3. And that really doesn't do much for me there. This would be minus 8x.
Are you using the oven?
Still. Yeah, I'm not sure about this one. I don't remember ever doing this one. Let's try to Google it real fast. Can you go back to that problem? Back to your screen.
Brainly.com is a really good website. For what? Looking up stuff. Brainly? Yeah. Brainly. Has all the answers I need for ingenuities and stuff. Cool. All the answers for ingenuity? Yeah, like the stuff I have to do in ingenuity. Is it know that it's ingenuity stuff? Yeah, it just has a lot of answers. Oh, that's cool. Yeah. Brainly? Brainly.
Ooh, I got some pictures here. I think I could find it.
B-R-A-I-N. Hold on. You think you're talking my kids? My 6th graders? Hmm? Think you're talking my 6th graders? Yeah. Cool.
So that one has x is 1 as a... So that would be x minus 1. I think you do that first. Let me see. Hold on.
I'm not using this. I'm going to put it back in the box.
We want to find all of the zeros of the degree 3 polynomial function. Then write p of x as a product of linear factors. Hold on one second, Timmy. So for a quick review, the complex factorization theorem states that if we have a polynomial of degree n, then there are exactly n complex zeros as long as we count multiplicity. So if we find all the complex zeros, then we can write the given polynomial function as a product of linear factors. This x-intercept is -4, where the point would be -4. This x equals -4 makes this factor equal to 0. The remaining factor would be a degree 2 factor or a quadratic factor. To find the quadratic factor, we're going to take our polynomial function and divide by x plus 4. So if we want to take x cubed plus 4x squared plus 9x plus 36 and divide this by x plus 4, we could use either long division or synthetic division. Let's go ahead and use synthetic division to form this division. So for dividing by... Alright, you ready? I got this one, Sadie. You want to switch over? Alright, so that says x equals 1 is a 0. So that means I'm writing that as x minus 1. So that means I'm taking this x to the third plus x squared minus 8x plus 6. And I'm dividing this whole thing by x minus 1. So this becomes algebraic long division. We have not done any of these together, so it might look a little weird. But you just do it the same old way you would regular long division. Set it up just like that. I'm dividing this into the top part. I look at this x and see what it takes to times it to get this x to the third. That would be x squared, and I write that right above the second term. I know it's kind of weird. And now I distribute this. So this gives me x to the third minus x squared. And long division is always subtracting, so these turns a minus. This turns that to plus, so I get 2 of these x squareds. Bring down this minus 8x and keep going. What times this x gives me 2x squared, and that would be positive 2x. Distribute it. 2x times x is 2x squared. 2x times negative 1 is negative 2x. And then you subtract. These cancel. Turns to plus. This is negative 6x. Bring down the plus 6. This would be minus 6. Distribute. Subtract. Turns to plus. Turns to minus. So that's it. X squared plus 2x minus 6. Algebraic long division. We have not done any of those. So I'm sorry that we did that. So I did that so quick.
Jaden, you want to say an old middle school graduation picture of Nancy and Kim, Gail? I don't know who that is in the middle.
I don't know. But I know this is right. Let's knock it out and move on.
Kim, Nancy.
Job.
I don't know who that is. It's probably Shauna, you don't know. And Gail.
That's Gail.
God, remember, these are the tough ones. Let's look for 1 second. Didn't you just do some of these? Like, I thought when you were working on some of the sections on your own. You did. I thought you did. No? I think I got it right here. Okay, so we can figure this one out. Easy peasy. So the first one, 14 gallons of fuel, weigh 2,077. The other one, 40 gallons of fuel, weigh 2,200. What's the new one after 48 gallons for X? Alright, we got it. You want to switch over? Okay, so those are my coordinates. So if I find my slope, I'm going to go this way. Out here! No, dogs. Go lay down. They're wrestling by my feet. I think they're getting hungry. So, 2,077 minus 2220 over 14 minus 40. That will give me the slope. Oops. 2,077 minus 2220 is... Sorry, using the calculator on my phone. Misplaced my scientific calculator. That's negative 143. This is negative 26. So that gives me 5.5 as my rate of change, my slope. So now if I can you go back to that chart? Does it have that chart? Can you go back to your page? Oh, it doesn't have the y-intercept. Alright, so I gotta find the y-intercept myself. So if I take that rate of change and maybe use this one to plug in, I could find that starting point, that y-intercept. So 5.5 times 40 is 220. So if I minus 220 from 2,200, gives me 2,000. So that equation I could use to plug in 48 up here is 5.5x plus 2,000. So let's do that. Let's plug in 48 here. So 2,264 I'm getting for that one. Finding the slope, finding the y-intercept, and then plugging in that new value for x, 48 gallons, to find the pounds, I guess that would be. Well, there you go. Alright, domain. So domain cannot be 5 on this one. So that would be negative infinity 5 union 5 positive infinity. That one's pretty easy. So because see how 5 would make that 0 on the bottom of that fraction? So 5 is the bad number. So domain could be all numbers from negative infinity to 5, and then union 5 positive infinity. But hold on 1 second though. The top part, I can't x minus 1 has to be bigger than 0. So x has to be any number bigger than 1. So that means from negative infinity to 1. We're going to have to change that. So delete that second part of that answer there. Because I was looking at the top part of that fraction, it can't have it be a negative underneath the radical. So it's got to be all numbers bigger than 1. So the next inner part here, so I'm sorry, you're going to have to erase that whole answer there. Get rid of that whole thing. So it's going to go from negative infinity to 1, comma, and then union from 1 to 5. Wait, that can't be right.
Why is the oven
already? 1.
No, I heard it beep a while ago. Oh, you did?
Oh man, let's see. Can't be.
Beeped a while ago. I'm gonna remake this one.
Can't be 5. It has to be bigger than 1.
Are you gonna put on your
So
uniform?
hold on a second.
Okay. Not my Eagles one. Don't I have some AYSO ones? Oh, you want to put the same shirt on? That'd be funny. Yeah. If it's not in your closet, Dad
Must be
has
bigger
gotten a
than
back
so
bug
from
down
here.
in the garage, and it had all your old uniforms and stuff in it.
Alright, so we're going to change this up. It's going to be erase that whole answer there.
Today or tomorrow?
Sorry about that. Alright, so the first one's going to be rounded bracket 1, comma, to 5, and then union symbol 5 to infinity. There we go. Pretty sure about that one. Easy peasy. Just did these yesterday. Not right now, just you. What's that? Well, they're starting to make us teachers have like office hours and do like these little kind of Zoom sessions to try to help students who are struggling. So starting next week, I'm going to be doing more of that, but that still doesn't, it's like 90 minutes a day. Shouldn't be too bad. Alright, I think I got a picture of this one. Alright, you ready? Switch over. Okay, so this one I'm going to write it as a log. I'm going to write this as log 32 equals, in parentheses, negative x minus 2 log 16. So I brought this power down, log this base right here, and now I'm going to write this as log 32 equals, distributing this, negative x log 16 minus 2 log 16. I'm going to add 2 log 16. That gives me log 32 plus 2 log 16 equals negative x.
Okay.
Log 16. And to get this x by itself, I'm going to divide by negative.
And I decide not to go on another pill.
Log 16.
What do you mean?
It's like, I don't know. What if I just decide I don't want to
Take it anymore?
No. Change my pill.
That's fine.
I feel like we just waste that pill.
That's okay.
I'm pretty sure. That's all x right there. Hold on 1 second though. Let me double check that. Negative x. It doesn't let you do log. You can only type numbers. Maybe I don't have pictures. Let me look. Alright, here we go. Alright, I found it. Nope, I found it.
You decide to do whatever you want to do.
Okay, so don't erase that yet. Log 32 equal log 16 negative x.
You were just out there.
2.
Weirdo.
So that gives me me log 32. This, it doesn't let you type in any logs on here.
Sharing Danny.
Okay. All right. I think what they do is they do 32 is for. Wait. Let's see.
It's like Dad's hair, but
2 to the what power is 32? Do you know? Let's find that. It's an eighth.
Will you send me the picture of me and Lucy?
yeah, the one that's high up or all of them?
High up.
This, so 32 is 2 to the 5th. 16 is 2 to the 4th power.
Get it?
Yeah, thank you.
Sure.
Times negative x minus 2. I think, yeah, you want to switch over? I think I got this one, Sabi. I'll show you. So I changed 32 into a base factor of 2 because 2 to the 5th power is 32. I turned 16 into a base power of 2 also, 2 to the 4th. When I log these two, anytime you have the same base power, all I'm doing is solving these top parts. So I'm going to write this as 5 equals 4 distributed times negative x minus 2, and I just got to solve that for x. So that gives me 5 equals negative 4x minus 8. I'm going to add 8 right there. I get 13 equals negative 4x. Divide by negative 4. So I think it's negative 13/4. Try that. Yep. Use that middle one. Oh no, I didn't even see that one. The secant. So a secant, you're just plugging in those numbers into the equation and doing the math, and then writing the equation of the slope through those 2 points. That shouldn't be too bad. Alright, let me write those down. Okay. All right, here we go. What'd you make? No, looks. Looks yummy. All right, sounds good. Looks yummy and fizzy. Make me thirsty. All right, so on the screen here I have -4, and then underneath it is that function that it gave me. I plugged in -4 where x used to be. So -4 to the third power is -64 plus 3 is -61. For the second one, I took 2, plugged into that same equation. 2 to the third plus 3 gave me 8 plus 3, which is 11. Found my slope by finding the difference of my y values. 11 minus 61 over 2 minus 4 gave me a slope of 12. Put that in for m. Used this point for x and y. Plugged in y for 11. Plugged in 2 for x. Solve for b. And after all that, taking that b, -13, and that slope, I'm pretty sure your equation of that secant line is right there, 12x minus 13. And again, I got that by finding those 2 points and then finding the equation to those 2 points. So there you go. Getting to the end, almost done. Oh, we're done. What's it say? What's your homework? You got one section? Let's knock it out. That's due today. Hopefully you didn't pile on a bunch of homework. Okay, let's see what we can get done. Okay. So what are you looking at there? How do you know you only have 9? Oh, right there, 9. Okay, let's do it. Let's take a picture of that. These look very familiar. So, ooh, you know what? Yeah, 5.5% compounded annually. Ooh, these were the ones we were missing, remember? So, let's take a picture of that. Yeah, these are the ones that really stumped us. Maybe tonight will be the night we get them right. So go back to the original problem. Interest compounded annually. I'm adding it. $25,000 times. Must be more. All right, go down a little bit. We need the smallest whole number that satisfies the inequality. Okay. You ready? These were our nemesis. I remember these suck. But we're going to get them right today. Alright, so that's the wording that confused us, because that last problem took the percent and added it to 100. But see how this one is each year loses 20% of its value? So that means I'm using 80% right there. If that makes sense. Right? So if each year you're losing 80% or 20% of your value, you're only having 80% each year, I hope. I think that's right. So I'm going to write that as 38 times 17,600 times 0.8 to the t power has to be 17,600 or less. So that means 0.8 t has to be more than.
Yeah.
Alright, you want to switch over?
You could tell them there's chicken if you want that.
Okay, so 20% going down each year. I'm using this as my base percent. It wants 17,600 or less. So that means my inequality goes like this. 0.8 to the t power has to be more than.
What are you trying to do, bud? What are you doing, Luke?
Has to be.
What do you need? What?
God, I'm confused. Sorry, Sabri. Brain's freezing a little bit there. So, no, I want to get these. I'm dedicated. So 15 or less would be 14. 13, 12 would be less than 15. So yeah, 0.8 t has to be less than whatever this value is right here.
No.
So if I divide those out, uh, 38,000 divided by 17, what's that give you? Yep, so I get 0.216 if I round it. Alright, so let's plug in some numbers. If I do now I really need my calculator, but let's try it. Okay, so if I gotta plug in a bunch of values into this and see which value range gives me numbers less than 0.216. So if I do 0.8 to the 5th power, that gives me 0.327, that's too high. If I do 0.8 to the 3rd power, that's 0.512. God, see, this is showing me again. I'm probably doing this wrong. Can you go back to the original problem, Sabri? Oh yeah, I have that fraction backwards. It's 0.8 t less than the initial values, so that would be 17,600 divided by 38. So I think I divided those numbers wrong. So instead of 38,000, it's really 176,000 0.176 with 2 zeros divided by 3/8 with 3 zeros. So 0.8 t has to be less than 0.463 I'm showing. So if I do 0.8 to the third power, that gave me 0.512. When I do 0.8 to the fifth power, that gives me 0.327. I gotta have a number less than this. Let's do 0.8 to the fourth. Let's see, 0.8.
What?
That gives me 0.4096. So when I go 8 to the third, that's too high, right? 8 to the fourth was just under. 8 to the fifth was under. 8 to the sixth will be under. So it looks like the fourth, that was the smallest one. Try that. I'm pretty sure if not, we'll have to look at, because I know we're close. That's what I'm thinking. Yay! Hallelujah. Let's finish this one, Sabri. Hate these problems.
No.
Alright, compounded annually, so I'm adding
No.
to 100, so that's 1.0875.
Stop attacking her.
How many years to accumulate 2,000 or more? Principal. It's the initial. That's the final amount, so it'll be 2. One times 1 t equals